In this video, we are going to take up some of the questions from the 8.2, 8.3 formative assessment for grade 9 math. I won't be paying much attention to my form in this case, but you need to make sure you are paying attention to that. I'm just going to go over most of the strategies and the approach taken to do each question to make sure that you understand what you need to do. But again, form is important. I'm just bypassing it now, but on your work, you should make sure you follow proper form to build the habit, which you may not already have yet. So start building the habit early and often. Here we go. We're going to start with the first question. Determine the area and perimeter of the following composite shapes. So there's two things we have to find, the area and the perimeter. I'm going to start off with the perimeter. Remember, perimeter means basically just adding up all the sides. So you have 3 meters, 3 meters, 3 meters, 6 meters. But then don't forget there's also a side over here that you're not paying attention to if you don't look at it closely, and a side over here. So this side here is pretty easy to find. Let's just call it side A. And this side here, we'll call it side B for now. If you look carefully, this whole side here is 6 meters, and this side here is 3 meters. So this side, so 3, just to show you what I would do, 3 meters plus side A would have to be equal to 6 meters. So if you were solving for A, which is really what you're doing when you're doing this, you would get A is equal to 6 minus 3, and so that would be 3. So this is 3 as well. And then if you want to find, well, side B, you're just going to realize that side B, the length over here, is equal to this length and this length over here. So 3 plus 3, that would be 6. It already looks like a 6, so let's just put 6 there. So our perimeter is going to be your 3 plus 3 plus 3 plus 3 plus 6 plus 6. So we have 1, 2, 3, 4. So that's 3 times 4 is 12. And then 6 plus 6 is 12 plus 12. Gives you 24. So we have that. So we can take a look to see if in our multiple choice there's any problems that have 24. Yep, there is one here, but you can't select that answer yet because look, there's another one that has 24 as a perimeter as well. And don't forget it's 24 meters. So we can cross at least the first two out, and then let's go and try to find the surface area. Now this is a composite shape, which means that it's made up of more than one shape, and there's a few ways you could approach this problem. We can find the surface area of, let's say, this first shape here, so the rectangle, let's call it rectangle 1, and then we can find the surface area of this shape here, let's call it shape 2, and then we can add them together. So for the rectangle 1, its surface area, you're just going to do its length times width, so we're going to do, for 1, the area is 3 meters times 6 meters, so 3 meters times 6 meters gives you 18 meters squared. And then for the next one, we'll just do, for surface area of 2, we do 3 times 3. So surface area of 2, I should put A1, A2, is 3 meters times 3 meters. And that gives us 9 meters squared. And then we have to add the two together. So A1 plus A2 is 18 plus 9, 27 meters squared. And so this one here would be our correct answer. So now we're going to go and try the next question. Again, please pay attention to form. You will be assessed on form in your assessments going forward in grade 9, 10, and if you continue in math. So pay attention to that detail. Look at the rubrics provided when it comes to your assessments. You have the resources. You just have to build the habits. Okay, so let's go ahead and move down to the next question. We have another composite shape problem where we need to find the area and the perimeter again. So read those questions carefully. Some students, when they do a test, they only read one of those words and they only do one of them and get half the marks. Also, did I round to the right? There was no rounding here. So our next thing we have to read carefully is rounding to the nearest tenth. So we have to pay attention to that as well when we're doing our problem. So composite shape, we have two shapes. We have shape 1 over here and shape 2 over here. We have a triangle and we have a semicircle, so a half circle. And so we're going to start off with the area first. The area is pretty straightforward. First we'll find the area of shape 2, which is our triangle, and that's the base times height divided by 2. And it's easy to make a mistake here. Most people will get the height is 14, so they'll put 14. And then when it comes to the base, you need to realize the base is not 9. It's actually, so this value here is 9, and so is this value. So the base of your entire triangle would be the 9 plus the 9, which is 18. So 14 times 18 divided by 2. I should have put my units in there, but again, you're going to pay attention to form. I'm just showing you strategy here. 14 times 18 divided by 2. I get 126 centimeters squared because it's surface area. And then I have to find the area of the circle. And so remember, the area of the circle is pi r squared. But the problem is that it's a semicircle, so you need to remember to divide that by 2. If you forget to do that, then you're in trouble. So it's going to be pi times the radius, which is given to us. It's 9 squared divided by 2. Plug that into your calculator, so you get 9 squared is 81 times pi, and then divide that by 2, and you get 127.2345, keeps going. Then you can add these two together, so plus 126, and you get 253.234, but again, we need to round to the nearest tenth, so 0.2, and then it'll be centimeters squared. So let's take a look and see if there's a 253 anywhere. There is. There's one here. There's one here as well. So you can't just choose the first answer that you see with the correct answer for area. You also need to verify your perimeter. We have two different perimeters given here, and oftentimes in multiple choice questions, we don't just choose random arbitrary numbers in the choices. We put numbers in where you're likely to make errors, where you're likely to have some misconceptions, so that we don't make those mistakes. Try to avoid making those mistakes. We need to find a perimeter. So we need to know all these different side lengths over here. We need to know the length of A, B, and C. And so for C, it's pretty straightforward. You're just going to use the formula for diameter. So length of C is going to be the formula for circumference. So pi times diameter, which is and don't forget, it's divided by 2 because it's a semicircle. So pi times diameter, which is 18, divided by 2, which would be pi times 18 divided by 2, 28.274. I'm not rounding yet, I'll do that after. 28.274 centimeters. So that would be the measurement there. We need to find the length of this side of the triangle, and you can use our good old theorem here. So we have this length here and this length here. We can find our hypotenuse by simply doing, so b squared is equal to 9 squared plus 14 squared. And then you can find b by doing the square root of that. So let's just do 9 squared plus 14 squared. We get 277. But remember that we're looking for b, so to find b, we take the square root of 277. And we get 16.643, so on and so forth. So that's the length here. By the same process, we would also get the same length here. You know it's an isosceles triangle. Now you can add all these up, the 16.643 to there, and then the semicircle diameter as well, circumference as well. So 28.274 plus 16.643 plus 16.643, and that gives us 61.5. So So make sure you round to one decimal place, round it to the nearest tenth. And so this one's off here, so that wouldn't be right. So this would be the correct answer over here. Okay, so we'll go to the next question. Again, I didn't do proper form. You need to do proper form. I just showed you strategy. Areas where you might make mistakes, areas where how you should approach the problem, what shapes you're dealing with. Now, some of you might say, oh, I went a little fast. Well, this is a video. So you can pause it and then rewind there and review parts you didn't quite get. Okay, so we have time for one more problem in this half of the video. I'll make the second half after. So here we have a circle and a square. We need to find the area of the shaded region. So we want the shaded parts here, 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 and here. So basically we want to find the area of the circle, so area of circle, and we want to take away the area of the square. I'm just going to draw a little square there. So the area of the circle is pretty easy. We're going to do, so area of circle is equal to pi r squared, which is equal to pi times the radius. So the radius of the circle is 7. Pi times 7 squared. It's a full circle this time, so no need to divide by 2. So we're just doing 49, which is 7 squared times pi. And then we get 153.93. And now don't forget, this is in meters, so meters squared. I'm going to round later. Now the area of the square is a tricky part here. Many of you might have taken the 7 as being the length of the square here, but it's not. You actually need to find the length of the square. If you notice, if you extend, this goes halfway through the square. So if you extend this line, this other part here must be 7. So what that means is that this total is 14. Now this is a square, so you know that this is a right-angled triangle that has formed here. And you have two sides. You have side A and side B here. The thing is that A and B must be the same because this is a square. Square has the squares have the same side length. So instead of calling this B, we'll just make this side A. And so what I've done here is I know that 14 squared is equal to A squared plus A squared. It's like saying A squared plus B squared is equal to C squared. But in this case, my B squared is A squared because they're the same length. So 14 squared is equal to A squared plus A squared. That's one variable that I can collect, where I can collect the like terms and add them together. So that means that 14 squared is equal to 2A squared. I can solve by dividing by 2. Well, let's not do that yet. Let's do that after. So I have 14 squared is equal to A squared plus A squared. And what I'm going to do is I'm going to first make my 14 squared, get an answer for that. So that gives us 196. Just so it's easier to see how to divide by 2 here, is equal to 2A squared. Now I'm going to divide by 2. And I get 98 is equal to A squared. The opposite of squaring is to take a square root, so A is equal to the square root of 98. So take the square root of 98, and that gives you about 9.89, so on and so forth. So 9.899 centimeters. So that is the actual length and width, or side length of the square. So 9.899 centimeters. So that means to find the surface area of the square, I just do 9.899 multiplied by itself, so I'm just squaring it. And I get 98, which would be what I've got here. I'm just doing a reverse operation there. Now I can do, and let's write meter squared. Now I can subtract these two numbers, so Subtract 98 from 153, so 153